Hello, is the PowerPoint visible?
Yes, sir.
Yeah. Okay. So we will start today's session. In the last few classes, we have discussed about the different kinds of peripherals, variety of peripherals from analog to digital, and developed interfacing circuits to the microcontroller LPC2148, and also we have written the programs, the driver programs to interface different varieties of devices. Today we will see another practical situation or the practical requirement which is extensively required in the industry when you want to implement or employ the embedded systems. I say that it's very commonly used, that is what we call as a high-powered devices. What do you mean by high-powered devices? The devices which requires more than normal your microcontroller working voltages. For example, let's say you want to switch on the bulb or fan. It requires 220 volts and requires a current of 0.1 to 0.2 amps. They work if you purchase a bulb 60 watts, 100 watts like that. That means that they work at the 220 volts and 0.2, 0.3 amps will be there. Or if you want to run a bigger motor, you require 24 voltage. A power supply is required many times. So sometimes you also require certain stepper motors which work at 48 volts also. That means that, so some LED strips you want to design using an LED strips, some circuits, you require a plus 12 volts. So there are these devices which requires more than plus 3.3 voltage or plus 5 volts, which require to operate at these voltages and require to work at the currents which cannot be supplied by the microcontroller. We know that microcontroller can supply only in terms of milliamperes. It can supply only 3.3 voltage. But I require to operate at different voltage in the industry. If you go and commission any embedded system in an industry environment, you will get variety of sensors, variety of devices. They are all not work at the range of your microcontrollers. Then always a question comes into picture. What is a way? What is a way we can able to handle that one? We will handle one such device and we'll see that how it may be possible. We'll see the practical way, what is available in the industry, how we have to handle it. Now let's say you purchase the new bulb to the house. You want to put this bulb in a particular place in the house or the industry. Now what you do immediately? Check the bulb. If the bulb is working at 220 volts, you ask him. If it's 220 volts, what you do? Then immediately you just connect a wire for that. So you make the connection to the wire. So one to the bulb, the device. So that means that you are making a connection to a device first. After making the connection to the device, you take this whatever available you have available, that you plug into the system here. So what is the plug-in I have to do to the system? Since it's a 220 volts, now every socket in the house will have a 220 volts. So what I will do is, so I will just connect them one to the here. That means that I insert that, I'll connect it here. So inside they would have put the switch for this one to operate. If I press the switch, you get the bulb on. If I switch off, the bulb will be off. This is what we have seen, these type of circuits which are extensively used in all the places which are being used here. Now, these circuits now, I want to control, I want to make it smart by introducing a microcontroller to the system. So what I want to do is, I will introduce a controller now. So I will just go for one microcontroller. Let's say I've gone for a LPC2148. Now, let us assume that I'm going to take a lot of ports are available. I'm going to use one port. Let's say the name of the port is, so name of the port I'm going to take is one port, that is P0.1. So P0.0, let's say we'll take the first pin. Let's say, so this is the pin I want to interface. Now I want to develop a program. So through the program, I should be able to control this smart system. That is a light, which only when required I have to switch on or switch off. The advantage of controlling through the microcontroller is there is a possibility of connecting a sensors to the microcontroller, and the microcontroller is capable of processing the data from the sensor. And only when it's required, you are making switching it on. That is why we are making normal light is what? It's not a smart system. Because why? You physically go there, switch on and switch off. If I take a controller, if I introduce, it becomes a smart. Why I do a smart? You can connect a light sensor, an LDR to this one. So the moment I connect a sensor here and a sensor here, so what will happen? You have the capability to acquire the environment data. So whenever you are able to acquire environment data, process the data after converting into digital, after digitizing it, then it becomes what? System is smart. That means that when there is no light, automatically the system is on. Or let's say you have connected another sensor. So let's say the door sensor or person identifying the sensor. You have a PIR sensor, so there, when a person enters into the room, you can identify them. That means that as soon as a person enters, so you can switch on the light. And based on his requirement, you can learn his behaviors. You can make it what? Little dark, a little light. Light intensity also you can control. Instead of this LED, if you use LED bulbs, you can control the intensity also. That means that the whole house, you can make it smart. You can make the LEDs glow, depends upon the requirement of the different person who enters into the room. Or whenever the night, automatically it's on. In the morning, if you don't switch off, it can be switched off automatically based on the light sensor. So many things you can able to implement whenever you are able to handle high power devices and connect them to the microcontroller. Let's see that what are the challenges. Can I connect now this wire directly? Now I will remove this one. So I don't want to connect through this one. Now what I'll do is, so I will remove this connection. So it is not there now. I'll remove this connection. Now it's not, the switch is not there. So I've removed the switch. I am not interested to connect to this one switch directly. So what I'll do is, now I have a pin is available here. I want to connect it. Can I connect this directly to this bulb and ground? So always what is required? So ground is a point which is an essential. Always ground is a point which is an essential. So that ground is called as what? VSS pin in the microcontroller. Let's say I have a ground pin. Can I connect this directly here? Is it possible? If it is not possible, why it's not possible? Number one, this operates at 220 volts as I said. Since it operates at 220 volts, your microcontroller is not able to provide that much of voltage to the P0.0. Maximum I can provide 3.3 volts. So this is not possible. Next, current. Let's say it requires around 0.1 ampere is required for this bulb, assuming that it's a small wattage bulb. Yes or no? So 220 volts into 0.1, you just multiply. It's a small wattage bulb. Let's say 22 watts, a 20 watts bulb. Can you supply 0.1 amps here? No. It can supply only what in terms of milliamperes. Yes or no? Around 10 milliamperes like that. It's a very small current you can able to supply this through this wire. So that means that is also not possible. So both requirement of the voltage and the current is not satisfied by what is called as this microcontroller, whatever you're talking about. It is applicable for any microcontroller. Now what do I require? Now I have to introduce some concept, so which facilitates me to connect the power supply to this bulb. How do we do it? So let's understand that one now. So now we will see that what are the ways I can able to do it. Since it is not possible now to connect directly to this one, now I have to go for some logics. I have to go for it. So what are the logics for that? We will see that now. Now, what is an equipment I require now? That equipment should be able to connect the microcontroller to this one. What are the properties of that equipment? Let's assume that I have a device. I have brought some device, purchased some device. I have brought some device. What is the properties of that? I want to use this device, whatever the device I've used here. So as an interface between this microcontroller and this, what is called as this device, whatever I want to interface it. Now, what are the facilities of this device? On one side of this one, that is if I divide it into half portion, one side of this one should be able to handle or work at the low voltages, at the low currents. That means that at the rate of 3.3 voltage or 5 voltage, they should be able to work it. Other half of this device should be able to handle large voltages and the large currents. So if this properties can be implemented in any of the device in the circuit, then that circuit can be introduced to solve this problem. So what is the problem I have? High power device is there. I require a large voltage, large current. Now I have a microcontroller which has a low power and a low voltage and low current. I want to handle them. But I have a power supply. Already the power supply is there. But only thing I want to control that through this microcontroller. So I'm thinking about a device which can provide an interface or a bridge between the low power microcontroller and a high power system. So that type of devices which can able to handle such low current and low voltages and operate high voltage and high currents, you can immediately tell to your mind that is, I can use a transistor, because transistor we have used in the stepper motor experiment. Yes or no? The low voltages and low current. That is okay. The transistors, if there is a 12 volts, 8 voltage, 6 voltage like that, I can use a transistor, I can use it. If let's say if it's a higher voltages, let's say 220 volts, 48 volts, or 110 volts, then normal transistors, what is available, or whatever you use in the circuits cannot be used. I cannot, you can use ULN 2803 or normal SL100, I cannot use it. Because why? I have to operate a high power devices. I'm not talking about the 6 volts or the 12 volts, high power device, 220 volts. In such cases, one of the beautiful way you can able to do is that device is called as a relays. So relays or the experiment, relays or the devices which are used in the market to introduce or to implement this type of jobs. How does a relays works and what is the principle of that? We will see that now. Now, look at this diagram for a moment. So what does this device will do? This device, as you see inside, and which is represented by the schematic diagram like this one. This is a symbol of the relay. So these relays generally will be available of two types. Earlier olden days, there were only one type of relays called as mechanical relays, called as a electromechanical relays. So these electromechanical relays will work on the basic principle of electromagnets. So this electromagnets will have a movement inside. That means that whenever you energize this electromagnet, you get a tuck sound. When you release again, you get a tuck sound. That means that you can listen tuck, tuck, tuck sound. You can see that a lot of refrigerator or old systems, even if you go and just watch there, whenever the operation, you will listen small sound, tuck, tuck, sometimes a flappen. That means that whenever there is a change in the temperature, whenever the change in the mode, whenever something fan is on, you can listen this sound. So whenever you listen sound in an embedded system, and you're controlling high power devices, just think that it's an electromechanical relay. Now, nowadays, what is the disadvantage of these electromechanical relays? That's the physical moment is there. Wherever you know that some physical moment is there, the life is less. Even though all the components, what is present here is not very cost effective. You can get a relays for 60 rupees or 70 rupees, but the life is less. So, and they may not operate at a very high speed. For example, I want to work at 1 kilohertz. I want to switch off and on in a second, 100 times. These are not recommended. But whereas when high power devices, in this case, we are not operating at high frequency. When somebody walks into the room, you switch on. Or if the light is very less, you switch on. You don't require that much frequency is not required. You are not generating a waveform. You're just switching on and off. So such cases, you have to see that this mechanical relays, which is available 60 rupees, which generally work for 2 to 3 years without an issue. Sometimes even rarely uses it. 5 years also it can work. You have seen that. Some of them they have used in water purifiers. They'll work for at least 6-7 years without any issue. So depends upon the requirement, the frequency of operation. You can always choose this kind of mechanical relays or electromechanical relays. There's another kind of relay. We use a word called as solid state relays. We use a word called as solid state relay. So what is the meaning of a solid state relay? They have been not used any mechanical part inside. They use what is called as MOSFETs. So high current, high voltage MOSFETs are used inside. Since the MOSFETs are nothing but a solid state electronics, so you will not hear any sound, and the lifetime is infinity. In the sense that for the lifetime, when you purchase a product and put a solid state relay. So I have not seen in so many products we have deployed. So it will work for years, even 10 years. It will not going to cause any issue unless you damage that one. You over current or over voltage if you put on it, then only the issue. So these solid state relays also available. It is little costly, around 220 volts, 230 to 250 rupees. Around that range, you get a solid state relays. So it depends upon the requirement. You can always choose either electromechanical relay where the electromagnet is used, or you can use solid state relay where MOSFETs are being used to implement the solid state relay. Now, depends upon the application you have to choose. If there is a lots of operations there on and off, go for a solid state relay. If only once, say for example, in a day, 150 times, 60 times are there, this will work for years together. You can always use. And also, of course, apparent advantages, you can see that you can hear a sound with it working or not. Of course, that is not the reason. You can just, that's one of the observation you can make it. So either you can go for electromechanical relay or a solid state relay, you can go for it. Now once I've identified, I require a relay, and relay is a device which can handle on one side the low power microcontroller, on the other side it can handle the high power devices. My immediate observation is now let's build an interfacing circuit using a relay. Now let's understand how does a relay works, how does I can use that the different pins of the relay in my circuit. As you see here, and also you can see here, there is a moving part here. You can see that there is a moving part. That is, there is an electromagnet is there. When you energize the electromagnet, it moves to the other position. So that means that, so you can see here, there are what is called as, so 3 terminals are there here. You can see that there are 3 terminals are there. So what are those terminals? So here you can see that there is a 1, 2, 3 terminals are there. So these 3 terminals are connected or available on the right side of your relay. So this is the right side, and the right side of the relay you have that one. What is the right side of a relay you consist of? Right side relay, it consists of one common terminal which is attached to the spring, and so which will rest on one side of a terminal lead. So that means, let's say if this is a common terminal, yes or no. So this has come out as a pin in the relay. It is available as we call as a common terminal. This common terminal either can rest on this pin, or it can rest on this pin. So that means that it will be generally by default, it is resting on this pin. So whenever you are interested, I can make it move and rest on this pin. That means that instead of here, it can come and rest on this pin, get connected here. So that is why whichever the pin it rests normally, so that pin we call as a normally closed. In the sense, what closed in the sense what? There's a connection. You just see that common and NC, this is like a switch. It's like a switch. So that means the switch means what? You can open that, you can close it. So as the name say, NC means what? Normally closed. That means that if you don't energize, if you don't activate the relay, so normally closed gets connected to the common terminal. That is like, it's like a, so the common terminal, whatever the wire you have, and if you have an NC, so this is the pin you have an NC. So it is nothing but they are connected. So they are connected. So you can always say that C and NC are always connected when you don't energize, when you switch on the relay. So that means that this acts like a switch. That means that whatever I'm referring here, it is acting like a switch. So whenever you take these 2 terminals, C and NC, the current always flows here. So that is like a switch which is always closed. There's a point. Now let's understand what is the another terminal. So whenever I don't want this connection to continue, I want to stop this connection. That means that what? I should open this connection. Then what should I do it? I should make the connection which has been already resting on the NC to come and to the other, rest on the other side. How do you make it rest on the other sides? You have to, I said this is connected by a spring. The common terminal is connected by the spring, and it's a mechanical part. It's a metal plate. Now, you know that as per the electromagnetic theory, whenever you energize this electromagnet, because of the electromagnetism principle, this common terminal, that is, you can see that this plate gets, because of the spring, it gets attracted towards this side. When it gets attracted, what will happen? This terminal, common terminal, will make the movement, small movement. It's in terms of mm. So and come and rest on this point. So now what will happen? So the common which was there here, it is disconnected, and it makes another connection here. So now if this is the again common, now after the connection what I will make? I'll make a, now I energize the electromagnet. It come and gets connected to what here? Now what will happen? NC is open now. See that no connection is there between the NC. Even though NC is there, it's no connection is there. It is open now. So it's open now. Whereas here it gets connected to the open. So the common wire, the common terminal gets connected to the normally open. So now the current flows in this direction, current flows. So based on this principle, you can able to design your circuits. It is also called as, so single pole, double throw also. So you can just see that. So this can also be indicated like this. So you just look at that. This is like this diagram. You can see the diagram. So it's a single pole, double throw. That is a common is there. I can throw the terminal, common terminal gets connected to either normally closed or to the normally open. It's called as a single pole, double throw switch. Now, so once I have understood that, this is the relay, and the right half is nothing but this electromagnetic magnetism. You should always remember that this electromagnetic coil, electromagnet, is not physically connected to the other side. That means that this part A, the part A side, and the part B side There is no physical connection is there. There is a separation is there. Yes or no? Because of electromagnetism, it just pulls the common terminal to the other lead. That's all. This common terminal is never connected to this one, never touching this one. That means that there is a physical isolation between the A side and the B side. This is where the advantage of relays comes into picture. It is basically provides an isolation. There is no connection between the A and B. That is why the A side can able to connect to the microcontroller. The B side is connected to what? The high power current and voltage. Since even though the B is working at 220 volts and 0.1 amps, this generally they specify 3 amps. If you purchase the relay, no, they give a rating. What is the rating they generally give? If they say that 220 volts, so 2 amps or 4 amps or 5 amps, like that, they'll indicate on that. You should see that what is the requirement and you have to purchase that type of relay. For example, you are operating very high power, the bulbs which you require to set up a small event in front of the house. Generally, when you purchase such bulbs, they will work at 220 volts, but they work at a very high amperes. So in such cases, you require a 5 amps relays. So that means that depends upon the bulb you purchase, depends upon the situation you are going to face, you have to choose the proper relay capability. Since you just imagine that the B side is working at very high voltage, 220 volts and 1 amp, 2 amp. No way this part of the B part should touch the A part. If any touch happens, any connection happens, even a small stray connection happens, finish, your whole microcontroller board will get spoiled within a minute. So that means that the A and B are physically isolated. Only thing is, because of your creating electromagnetic, the electromagnetic effect, because of the electromagnetic radiation, that radiation is attracting this plate and making it move to here through the spring effect. The moment you release the again energization, because the spring is there, it go back and rest back to what? NC. So if there is no energy, you may ask the question, sir, how does it come back to the NC back? Because of the spring. So the spring is housed on that. You can see the small spring here. You can just put spring here. So because of the spring, it will just come back and rest on the NC points only. So this is how actually the separation of a small power device to a high power device can be achieved using a relay now. Now, having understood this one, now we'll start interfacing the relay to the microcontroller. Now, what should I do it? Now, so let us take now the microcontroller and analyze how we can able to build this circuit. So now I will just get the relay, and the relay I'll get it, and I'll place this relay so in my circuit. Now, so I will bring this relay and put it here. Now, what are the connections I have to make it? Now, to start with, to make explanation simple, I'll make certain assumption. Assume that the coil can be driven by the microcontroller, because coil is just creating electromagnet. The coil is not carrying the current of the bulb. You should always be very clear. The A side is not carrying the current or voltage of the B side. So coil is just creating a small electromagnetic radiation that is good enough to pull your spring. Yes or no? To pull the piece of metal to the other side. So that much of power is only required. Let's assume to start with, that is, it is capable of, so driven by the coil is driven by the microcontroller. So now what I'll do, I want to make a connection for that. So now I will make this connection to this one. So I will bring this system here. I will put a connection to the microcontroller. I'm making certain assumption. What is an assumption I'm making? I am making an assumption that the 3.3 voltage and small milliamps of current is sufficient to do this one. This I will make an assumption. I'm making it clear. And there is a ground is available here. What I will do is I'll connect the ground point of the microcontroller to the other point of this one. I'll make it. So I will just indicate it is nothing but VSS. So VSS is nothing but what? It's a ground point to the microcontroller. Now I connected. So one side my connection is done on the breadboard. I've just connected it. Now here I have to do it. Now what is the bulb? The device is available here. The AC supply is available here. I have to be able to handle that. Let's see how we can able to handle that now. Now, so I will bring this to here. I want to handle it. Now, how do I do it? Now, first of all, the connection which was there between the bulb and the AC is nothing but two wires was there directly connected. They have connecting what? Here one wire there directly we are connecting it. So we are connecting another wire to directly here. This is what the connection is there now. Now what I should do it? I should be able to bring some disconnection between these 2 points. I'll remove some connection here. I'll remove some connection here. So I'll take the scissor and cut this wire, one wire. So what I have done, I have taken this connection. I have brought this wire, yes or no? So if I'm directly put the plug, it is working here. Now what I'm doing is, so the bulb which is going to connect it here, I'll just remove one of the wire here. So this I can show in a different ways. Now I have just cut this wire now. Now I want to introduce the relay here. How do we start? Now, normally I don't want the light bulb should be off. Normally it should be off. Only when I require it should be on. That means that you don't want this device should be on normally. Then you should take what? Normally open. If the normally you want the switch to be, the LED should be always on, that is the bulb should be always on, you connect the normally closed. If you don't want normally should be always on, go to the normally open. That is how you decide whether you go for NC or NO. I want normally should be off, so I say NO. Now what I'll do, I'll take one line here, that is I'll take here the wire normally open. I will connect that wire to here. I'll bring that wire here and I'll make the connection here. So now I have connected normally open to this place. I've connected it. Now, shall I then, what about the normally closed, finished? Whenever you use one terminal, say NO, no way you are going to use NC. It's not required at all. So that means that it is finished. It is not used at all now. So once you use NO, put a into mark on NC. You are not going to use. In the relays, either you use what? NO or NC anyone use. You are not using the both. Am I audible?
Yes, sir.
Yeah. So now what I'll do is, now I have to provide another connection. Where do I connect another connection? There's a common terminal. So now I'll take the wire here. I'll take the common terminal. Then I will make the connection to here. So I'll make the connection to here. So this what will happen now, my connection is complete now. So I just cut one wire which was going directly here. In between the wire, I introduced this one. Now look at that. This wire has been introduced a small switch. Look at this, a switch is introduced here. Now what is the switch? Switch is always off. You can make it on whenever you require it. Now why it is able to carry now large current? Because it's a metal piece. This is also metal piece. See that there is no electronics is involved here. There is no electronics. You know that a metal, what does a wire is concerned inside? It's nothing but a metal piece, small strands of wire, yes or no? A small strands of wire, what you use in the electric shop, can able to drive a large current bulbs. Same metal, same strands of wire has been put as a metal plate in the connected here. Since there is no electronics here, look at here, no transistors there. So you can see no electronics here. So it's no transistor, no electronics, no diode, nothing is there. It's nothing but a metal. So since this metal is capable of handling large currents, so large voltages, so that means that you can able to make the switch handle on and off automatically and control large power devices. This is the secret here. This is the concept behind here. Because there's no electronics, there's no microcontroller here, and it each is nothing but a wire. It can able to handle large current, large voltage. Now my interfacing is completed. Now see that this is the power supply. So what is this power supply? This is the 220 volts. Let's say we'll assume as a 220 volts operating device, AC source. This is an AC 220 volts. Now I've introduced a relay. I'm controlling this one. Now by using a simple IO0 set equals, yes or no, 1 if I write it. So that means that P0.0 becomes on. Whenever you send 1 here, what will happen? The current flows and the electromagnet gets the winding get energized, and immediately you are pulling the common terminal gets connected to the NO and the current flows to the LED. So whenever you stop, you send the 0 through IO clear instruction, then what will happen? It's off. So you're implemented now an interfacing to the high power devices. But the problem with most of the, okay, we have solved this problem. So now this is a successful way of interfacing an high power device to a microcontroller. Now a small concept I'm introducing here. Of course, yes, I have assumed that the pin can drive the electromagnet. There is electromagnet coil here. But generally what will happen is in normally electromechanical relay, I'm not talking about solid state relay. Solid state relays which have been designed using a MOSFET, which can also be used to drive the large power devices, has capable of directly connecting to the microcontroller. They can handle 3.3 voltage or 5 volt directly, TTL you can connect it. But normal relays, electromechanical relays, which is available in the market, yes or no, these relays they cannot be operated directly by the P0.0 because these coils operate at 12 voltage. So now what is my requirement? So since these coils are 12 volt coil, they are called as a 12 volt coil. So the coil what is present here, this is a 12 volt coil. And since it's a 12 volt coil, I cannot drive them from the microcontroller. Then what should I do it? Then now I've introduced another concept here. Now, so I will remove this connection now here. So I will remove the connection between the microcontroller and the coil. Now I'll get a device which can drive 12 volts. We have studied already in the stepper motor experiments. It is possible to use a transistor to drive 12 volts point. Same concept I've used. Instead of using a discrete transistor, you can always go for an IC called as ULN2803. We have seen that this is a ULN2803 IC, a 16-pin, 20-pin IC, which is very commonly used in the industry for all driving applications around the 12 volts or 24 volts like that. Now I purchased one 2803 IC. It has got inbuilt, so 8 transistors are there. I'll take one transistor now. So what I'll do is now, so I will connect now the P0 point here. So I will connect that point, P0 point, to one of the transistors. So let's say I've connected to this point now. Done. Now output of that I'm using now, which can drive more voltage. Now I'll connect to this point. It's very important there. You cannot, this ULN2803 do not generate a voltage. You should always remember, it can only amplify a voltage. It's only transistor. So that does not mean that if you connect here, it supplies the 12 volts. No, that is why you should not connect to this point. Now, what should I do? Now I require an adapter. I require what is called 12 volts adapter is compulsory required. We have to purchase. So that is always the challenge. Whenever you want to drive the relay, you require another adapter. Power supply is also required. So I will purchase a 220 volts adapter. So one adapter I will purchase. So it's a 12 volts adapter. So 12 volts adapter I will purchase and use the 12 volts adapter now. Now this 12 volts adapter, whatever I am purchasing, now provides what is called as, so 2 points, which is nothing but the one is a 12 volts, other is the ground point it's going to purchase. Now these 2 points, ground and voltage, I will be using it. Where should I require it? So since this 12 volts coil requires the power supply 12 volts, I'll connecting this point to here. So I've just connected here now. Now the circuit connection is complete. So I purchased an IC, I've just connected here and this one. And all grounds you have to do properly, because why? So this ground and this chip ground should be common. Then only the circuit will work. Otherwise it will not work. Current will not flow. Because so whenever the current has to flow through the winding and it has to go to the ground, yes or no? This ground and this ground should be common. So I'll say that what? This common whatever there, yes or no? I will connect this to the same ground point. I'll call as G and D. And this also I'll call as a G and D. So I will put one ground connection here. I'll make it common. This ground is common. Now this ground is also common. So now its circuit is completed. Now see that what has happened. Now there is no requirement you have to connect the 12 volts to this chip. It's not required always. Only when you use a freewheeling diode. These are called as freewheeling diodes. The freewheeling diodes, whatever used in the transistors along with the load, this we will discuss in the DC motor section later in the probably in the next unit. So this freewheeling diodes makes it to work at a higher speed. Whenever you want to work the devices to switch on and off higher speeds, you want to release the coil energy. So in the reverse direction. That is why we use a freewheeling diode. It's called as a freewheeling diode. So I'm not using, only when you use a freewheeling diode, you have to connect the common to a 12 volts. Otherwise it's not required. But generally it's recommended connect the common point to 12 volts also, so that you can able to operate at a it releases the whatever the energy is there, back EMF, and it will be better to operate at a higher speeds. Now this is the connection. Look at that. I've used ULN2803 because I want to write, because my relay coil is 12 volts. So I have connected the P0.0 to this one. I connected this to here, and then I connected to this to the 12 volts to 12 volts adapter, and this ground, and this chip ground should be common. These are all one side. This is the A side circuit. Yes or no? This is the B side circuit. B side circuit, you just disconnected the power supply one line. You connected either to the NC or NO, the one end, other end you connected to the common terminal. So this completes about how high power devices can be interfaced to the microcontroller with the concepts of what is called the driver IC required here, the concept of the relay, when do you have to go for electromechanical relay, when you have to go for a solid state relay, how do you purchase the relay, yes or no? All these things you should be able to keep in mind whenever you want to implement an embedded system and you want to control the high power devices. Am I audible?
Yes, sir.
Yeah. So what is a program? Program is very simple. There's no code, no much code is there. So what is a code to write control electromagnetic relays? So it's a very simple circuit. First, so let's assume that P0.0 is connected to what is called as a relay. So set the direction of that first, and then what? How do you make it on? Just write one statement. So IO set is equal to 1 left at 0 because I'm assuming P0.0. Finish. It's on. After that, while loop is there. So this, just write a small program like that, your relay is on. So whenever you want to make the relay off, you can always use IO clear is equal to this statement. This is how you can able to use this program to switch on and switch off the relays. So this is a complete circuit I have given here. I have taken only one part, how I connected the bulb, and this one I have same thing I showed it. So this completes the discussion on the high power devices. Now let's learn on the second concept. So I'll go to the second concept now. So okay, so now we'll understand the second concept. Now, what is my second concept today? What is I'm going to discuss today? I'm going to discuss now how digital sensors can be interfaced. So my requirement is how digital sensors I can able to interface. So these digital sensors, number of sensors are available in the market. So they're used for number of applications in the industry. If you take any CAD/CAM machine, go to any manufacturing place, lot of machines will be running, and these machines will be using digital sensors. What is the meaning of a digital sensor? We have learned about analog sensor in the previous discussion. What is analog sensor? Analog sensor is the one which gives a value from 0 to 3.3, 0 to 5 voltage continuously. It varies with a reference to time, and it refers some physical quantity like temperature, humidity, air quality, like that. A digital sensor is always gives a two values, either on and off. For example, when do you use it? For example, you want to find out in case of CNC machine, computer numerical emissions. I want a particular, if the wheel is rotating, I want so the wheel has turned to a particular angle. If it wheel comes to a particular position, that means that I have to initiate certain action. That means that I want just only one, either on or off. Whether the wheel has reached a particular position, every circumference 360 degree, whenever it reaches 180 degree, I want one signal so that I can initiate other action in the machine. So that's all I require. For example, you want a punching, you are just continuously punching certain metal piece. So when do you want to punch? Only when the metal piece comes to the in front of the punch, then only you have to punch it. When there is no metal piece is there is no target is available, you cannot punch it. That means that as soon as it comes, you should be able to do it. That means that as soon as your target is placed, as soon as the metal plate is placed, you should get one signal. What is the signal? Yes, metal plate is placed. Yes or no? Like this, you take any CNC machine, there are a lot of on and off informations will be there. So just yes or no. So whenever you use such sensors, whenever you use that type of sensors, those sensors are popularly called as what is called as proximity sensors. So if you just type in anywhere in the Google, I want to show you that if you just type proximity sensor, number of sensors available in the market. So these are the proximity sensors which are available in the market. All these sensors are called as digital sensors, very commonly used in the industry. The beauty of these sensors is just 100 and 150 rupees. They are very reliable. They're very ready to use. You don't require to do any circuit. Nothing is there. Just take the sensor and start using in your projects. And it's very reliable. You will take any from Chinese machine to American machines or Indian machines, which are high quality. They use this machine. These sensors are extensively used in the industry to build the product. So anytime you require digital information, yes or no information, always choose in your project's proximity sensor. Don't choose any other sensor which is available for the project's prototype, which is used with the Arduino boards. Yes or no? Those are only for the project purpose. It will work. It will not. They are not going to work in a real-time environment. So you can go for proximity sensors. Now I have taken one such proximity sensor here and I place the picture here. Any proximity sensors, what is available? There's two types: capacitive proximity sensors and inductive proximity sensors. Irrespective of the principle, what is used to build the sensors, the output interface is common. All these sensors provide only 3 wires. You can look at the 3 wires are there here. So these 3 wires will provide the interface which can be used to interface to the microcontroller. Now we'll start learning about how we can do it. Now what are these 3 wires are there? So the one wire, what is being indicated here, so which is an output from this sensor, Let's say block 1. It's an output from the sensor. That means that, so I can write here this is nothing but it gives certain voltage called as an output voltage. Let's say it is an output. Now, the other 2 points, whatever the wires are there, they are the power supply to the sensors. You may ask the question, sir, why the sensor is a power supply? It's not like a LM35 or LDR. These sensors, what is available in the market, they are itself is a small embedded system. If you look at that, there's a big size is there. Inside, if you open it, there's a small electronic circuit is there. It is also sometimes microcontroller based. So that means that the sensor itself is embedded system. So if to make it work, you require to give a power supply. So this is a power supply point. So what is generally, so they generally expect around 6 to 30 voltage. So I'll just write as a now plus 12 volts. In this example, I've taken a plus 12 volts. Okay, you can make it to work at 24 volts also. So that means that you require a power supply to make it work. So these are the 2 wires where I have to connect a power supply. Now where do you get a power supply? Whenever you use a sensor, I purchased an adapter, 12 volts adapter, and the adapter comes like this. Cut this one end of the adapter, you will get 2 wires. Use that to the 12 volts here. That means that, so whenever you purchase an proximity sensor, don't start the project. Just see that proximity sensor is working or not. These proximity sensor will come with a small LED on the top side. You can see that you can see that here a small LED will be there. So this LED indicates whether the sensor is on or not. So how does a proximity sensors will work? A proximity sensors will work with a small metal. That means that the moment you identify a small metal near to that point within a 2 to 3 mm or maximum around 10 mm, it will give an indication here. So if you just look at the slide here, if you look at the slide here, okay, so I'll just show you. You can see that. So the small metal object is there. If this metal object comes to near to the proximity sensors, then it identifies there is something has come here. Immediately it generates a signal. It says signal is generated outside. That means that LED glows. So proximity sensors works with something metal object comes in proximity to the sensor. The amount of distance it has to come depends upon the sensor quality. Many times in building the projects, you don't require to be a lot of distance should be there. 2 mm or 3 mm is good enough. The sensor is capable because this sensor is a fixed. Always you can see that there is 2 nuts are provided. I can make the sensor fix on any of the fixed body on the machine. I can using the nuts, I can fix it. I can drill a hole. I can fix it both sides. That means that this becomes a fixed body. When this becomes a fixed, then what is the other point? The other point, metal plate is a part of a movement. So this will be part of some mechanical system which is being connected here. This mechanical system can be mobile. Yes or no? It's moving. For example, if it's in a wheel, so if you want to measure how many rotations a wheel is moving, or in the car, what speed the car is moving, or in auto rickshaw, how fast it's moving, you can just make to the wheel a small connection to the metal piece. You can able to put it somewhere. You can fix it. Then you make this as stationary. Then what will happen? This is a moving. Each time it moves here, it comes here. The position as soon as the metal point. See this is the wheel. I fix the metal point only 1 point. As soon as it moves, whenever the metal point comes near, it generates a 1 pulse. So it generates just 1 pulse. Let's say low to high 1 pulse. So then again after time another pulse it generates. That means that whenever it moves here, I'm getting a pulses. These pulses is an indication to the programmer. That means that so the event has occurred. Then immediately I initiate another device. So this how actually proximity sensors are used in the what is called CAD/CAM missions. So as soon as some event occurs, you get a pulse. So then you actuate it, some other device, maybe solenoid, maybe AC motor, maybe coil, maybe some what is called as a big motor, like that. Anything you can actuate based on the information whatever you get from this one. Now going back to here, circuit diagram. So that means that so I have now got the sensor. I know how it works now. So I will fix it at some other place in the machine. Then I have connected the power supply 12 volts to my adapter. I have connected it now. Now my system is ready on this side. That is, my system is ready on this side. That means that I have just connected the power supply to the adapter. So this is the 2 wires I've connected here. Now I have got what is called as output is coming here. Now this is my requirement. So now, so to use this type of sensors, so I've taken this one, I have connected here now. Now let's say it is available for me now. It's available for me now. I want to read this data, what is available in this circuit, that is in this sensor, yes or no. So from to the microcontroller. So now what I'll do is So I have taken a microcontroller, let's say LPC2148, I placed it here now. So this LPC2148 has got so many GPIO pins. I'll use one of the pins. Let's say I'm using P0.1. I'm using a line called P0.1. I'll use it. P0.1 I'm using. I want to connect this to the P0.1. I have to connect it. Now, how do I connect it? Is it possible to connect, directly take the output pin here and connect it here? Can I connect like this? Is it possible? Again, it's not possible. Of course, there are two challenges you have to handle it. It is not an output device. In case of earlier, you're driving the system using a relay, you're driving it now. Now, relay is not required here because sensor works at very high speed. That is, you keep getting a lot of pulses here. It's not, I cannot introduce some relay here. I can make this device drives the electromagnetic coil in the reverse direction. I can use this one. It is not a suitable solution. So now I want to connect this output to here. What are the challenges here? This output, whatever I'm going to generate, is at what voltage I have to observe it. Since I'm given a power supply 12 volts, the output is also 12 volts. That means that when there is no on, let's say this is 0 voltage. I'll assuming it. Let's say 0 voltage. Or it is what is 12 volts. That means that this this is what is called as a proximity sensor generates a 2 voltage. One is 0 voltage at 12 volts. Because why? It is operating at a 12 volts. So this voltage, 12 voltage, I cannot connect to the LPC because it works at a 3.3 volts. So its possibility is not there. Now, what is the other challenge? As I said, these sensors are extensively used as a part of a big machines. There's a lot of noise will be there. There's a lot of electromagnetic interference will be there. So a lot of stray currents, voltages will be there. A lot of unwanted pickups will be there. The interferences pickups will be there from this circuit. Now, this circuit, whatever which is there, should not affect my microcontroller, which is very in the sense sensitive. Even just a small voltages, which is above 3.3 voltage, a noise interference can spoil your microcontroller working. Or sometimes it may not get spoiled. What will happen? It gets reset. This is a very common problem in the industry. When you test in the laboratory, your project will work. Go and deploy that the customer place. You try at 100 places, 2 places it will work. Another 67 places it will not work. Sometimes it will work. Sometimes it will not work. So this is a common complaint in embedded systems. If you build your project using Raspberry Pi or Arduino, these are the things. Because it may work in the laboratory, it will not work in the industry. Because industry environment is different. A lot of inductive loads are there. A lot of tube lights will be there. A lot of fans will be there. Whenever the lot of inductive loads are there, it picks up a lot of noises. Whenever it picks up noises, what will happen? It gets reset. Whenever it gets reset, what will happen? Your program restarts from the beginning. That means that the machine starts stopping. Machine starts not working as expected. In such cases, I should be able to provide two things. One is the voltage translation I should be able to provide. That means 0 to 12 volts, I should bring it to what voltage level? I should bring it to what is called as, so 0 to 3.3 voltage or 0 to 5 volts I have to bring it. Many times I use a word called 5 volts, even though LPC works at 3.3 voltage, because all the GPIO pins are called as 5 volts tolerant. They've been designed as a 5 volts tolerant. Even if you give a 5 volts 0 voltage also, it accepts it. They're tolerate, but don't make it more than 5 volts. It can tolerate. It's better to give 3.3. If not possible also, 5 volts also it tolerate. So that means that you have to achieve the first objective of bringing the 0 to 12 volts to what is called a 0 to 5 volt. That is the first objective. The second objective is what you have to bring some isolation. That means that you have to connect it physically. You have to connect it physically from here to here. But is it possible to isolate them? Isolation means the data should come from here to here, but physically there should not be connection. The wire should not be there here. So then how do you achieve? To achieve these two objectives, that is providing the voltage translation and providing what is called as an isolation, opto-isolators are extensively used in the industry. So what is an opto-isolator? So these opto-isolators, you can see that these opto-isolators are a 4-pin ICs. You can see that PC817 is very popularly used in the industry. It's a 4-pin IC. So this 4-pin IC, it's logically inside. The diagram is represented like that. So now we will see that how the opto-isolator work. So these opto-isolators are also called as optocouplers. So we'll have a two components will be there. At the pin number 1 and 2, a diode is there. It's called as a normal not diode, IR LED or photodiode. We can call it a photo LED. So the other side, the B portion is called other two, the pins, it's called as a photo transistors. So you can call this is a side, this is called as a B side. You can see that A side is not connected to B side. Am I audible?
Yes, sir.
Yeah. A side is not connected to the B side. There is a separation is there. In the relay, we have seen that what is the concept used to separation? Electromagnet concept is used. Here, it's not an electromagnet concept. It's concepts of what is called as the photo LED and the photo transistor concept used. Light is a concept used. There's electromagnetic radiation is used. The light is a concept used. So what we do is, whenever we want to establish a connection between the microcontroller side to the opto-isolator, sorry, the proximity sensor. That means that I want to read the data coming from the proximity sensor and take the data and give it to my microcontroller. What should I do it? I should switch on this LED, photo LED. Whenever I switch on the photo LED, it emits the light. This light drives the base of the transistor and the transistor conducts. Normally, how do we excite the transistor base? By supplying what is called voltage and current. Here, I'm not supplying the voltage and current. I'm not connected. See that there is a base, there is no wire is there from the base to this point, A side. So it's physically they're different. So what is driving the base? It is the light is driving the base. So whenever you drive this one, there is a physical separation establishes between the A part and the B part. So this achieves the second objective of isolation, so that whatever the interference available on the machine side where you deployed this proximity sensor do not affect the microcontrollers, which is very sensitive in nature. Now, how do we achieve the first objective? That is a voltage translation. What is the voltage I require here? I require 5 volts. I build the circuit here now. I'll build the circuit here. Now, how do you build the circuit? Now I'll take this one. I will take this wire here. Now this is a transistor, just a transistor that's without a collector and emitter. I should establish the connection here such that it's suitable for my microcontroller. We know that microcontroller requires 5 volts or the 3.2 volts. So I will take this one wire on the breadboard. I'll place this photo transistor. I'll connect this to here. I'll make a connection. Now, how much is the voltage? I will take 3.3 voltage or 5 volts because it's tolerant. Whichever available in the board, I'll take that. I don't bring an adapter is not required because already you have a board is there. LPC2148 board is there. From there only you can take the power supply. You can connect to here 3.3 voltage. I've taken here. Now, the other point, I will not connect directly here. I should require because what will happen is if you just connect this point to be ground, it should be connected to ground. So I will connect this to the ground. I will connect this to the ground. So what I'll do is I'll connect this point to the ground. So I'll connect this to the ground. I'll place it. Now, one small connection is missing here. What is the connection is missing? See, for example, if I switch on this transistor, immediately what will happen? This conducts. This becomes a short. Whenever short 3.3 volts and ground gets shorted and your immediately microcontroller power supply or the board gets damaged. So I have to introduce what? Whenever such situation, you have to introduce what? A resistor here. So I introduce a small resistor here. Introduce a small resistor here. Let's say use around 4.7 kilo ohms or 10 kilo ohms of resistor, you can use it. So this I've used a small resistor I've used here. Because why this resistor required? So this resistor required, no, you should not get the burning. You should not get the burning of the power supply here. I'll get a resistor now. Now this point is important for me. Which point? This is the point. This is the point is important. I will connect to the port 0.1. I'll connect it. Now, what will happen? Let's observe this one. Now, whenever this transistor is off, that means that your P0.1 is connected to 3.0, you'll get a 1. So that means that you get a logical 1. You get a logical 1. So whenever the transistor is off, you will get it 1. Now, whenever the transistor is off, it gets shorted here. That is collector and emitter gets shorted. You will get what is called 0 here. So that means by this circuit, you can able to make that the required voltage and the required current, which is the first objective, has been satisfied to the microcontroller. Now, the input side, what is required? Now, since it works at a 12 voltage, what is the output you are getting it? The LED, what is there, the IR LED or the photo LED, which is there in opto isolator, can able to handle that voltage. But only thing is you cannot just, we know that any LED or any positive bias junction will take only less voltage. It will not take 12 volts. If I give directly 12 volts to this LED and connect this to ground, immediately photo or optocoupler will burn away. That means that it cannot able to handle the 12 volts because the junction takes only less voltage. Yes or no? So then what you have to do is, whenever such requirement is there, you have to use always an resistor. So now I will introduce one more resistor here. I will bring one more resistor. So I will bring one more resistor. So I will connect that resistor here. So I'll bring the resistor. Now connect this point to here. Now connect this point to here. Now I've done it. Now what will happen? This ground is there. This already, this has got a ground. The 12 volts and the ground you connected to this adapter. Take the same ground, so and connect that ground to here. Connect to this point here. Now my connection is done. So this is what you have to do. I have purchased the PC817. I have purchased an adapter, because whenever you use a proximity sensor, you require an adapter which drives the proper voltage and the current required for the sensor to work, because the voltage and current required for the sensor to work cannot be supplied by your microcontroller. And also for the safety purpose, we will have a different power source for this, different power source for this one. So using the adapter, I just power given is given to that. The output of the sensor, I've connected to the input pin, that is a pin number 1 of the PC817. Then the other point of the LED are connected to ground of this one. That means that my A side connection is complete. My B side connection is complete. Now my circuit diagram interfacing is complete. Now only thing is this ground and this ground both should be common. That means that whatever the ground you have here and this ground both should be common in the sense. So whatever you have the ground there, it should be common. So you should not combine this ground to this ground. Both are different grounds. Both are working at a different logics and different power supplies. So this ground, this complete circuit is different. This complete circuit is different, connected to ground here. And 3.3 volts from where you have taken from the same power supply which drives this LPC2148 board. Now, so once this is done, so whenever it's 1, transistor is 1, this LED conducts and this gets shorted, you will get a 0. That means that whenever the sensor is on, so what are the things you're going to get? Let's write here. So when the sensor is on, what is the voltage you get from the microcontroller? The 0 voltage you get on the microcontroller. So whenever the sensor is off, so you're going to get what is called as 1, that is a 3.3 voltage. So or it's called the logic 1, I can see that. So here it's a logic 0 I'm going to get. So why? Whenever the sensor is on, it drives the LED and this gets shorted. Whenever it gets shorted, what is the voltage I'm going to get? That is, this point becomes what? Ground. I'm getting a 0. That's what I've written. Whenever the sensor is off, no metal plate coming near to the sensor, it will always give the high voltage. So this how you can able to build an interfacing circuit and able to integrate a lot of industrial sensors to your microcontroller. Now, what is the program for this one? It's a simple program here also. I've just assumed that P0.1 is connected to the sensor. P0.0 is connected to the relay, like whatever we did in the previous circuit. I assume that relay is connected bulb. So whenever somebody enters the room, the door is moved, using the proximity sensor, I want to switch on the light of the room. This actually physically you can implement in your houses, this one. So how do I do it? P0.0 I connected to the relay. That is why I set the direction of the P0.0 as a output. Now, so I'm assuming the P0.1 is connected to the opto isolator. How do I read it? We know that IO pin. IO pin is an register. Through that I can read any pins of the port. So I'm reading which pin? P0.1. That is why 1U left shift by 1. So I'm reading the P0.1. So store the result in the result here. What does the result contains? Either it contains a 0 value or non-zero value. So that is why I can able to use in the if statement. If the result is 1 non-zero value, that means that I'm just switching off the relay. So if whenever the result is 0, that means that we have seen that opto oscillator gives a 0 means that means event has happened. That is why I put clear here, set here. So we have seen that. So we have understood that when I get a 0, what does it mean? That it means that some event has happened. Door is opened. That is why I'm looking for a 0. So what I'll do it. So that means that if the condition is 0, that is my result is 0, I will come to the else block. I will make the relay on. The tube light of the house is on. So this is a complete program for a smart door. So we have connected the proximity sensor with the nuts provided onto the door. You can easily fix it. On one side of the door where the sensor is placed, you just paste small metal piece in that, so that whenever the door is closed, you know that only 2 to 3 mm gap will be there. So automatically it will get activated. Only thing you have to purchase an adapter, fix the adapter somewhere into the power plug and connect the power supply. And the relay you just introduce into the light circuit. So then a smart door circuit has been implemented. So this is how you can implement a smart door using an isolators and a relay devices. And lots of projects you can able to build using these concepts and this programming. So if any doubt is there, you can just raise your doubt.
Sir, suppose it's not industrial scale.
Okay.
Then can we use voltage dividers instead of opto isolator?
No, that's what isolation you cannot achieve. No.